Hello students, welcome you all in today's class. In today's class, we are going to discuss about the most important topic of class 10th chemistry, carbon and its compound. Why I am saying that this topic is very important because according to the CBSE marking splitter, this topic is going to be the highest weightage 9 marks. You are listening right. This chapter is very important. You can score maximum marks after watching this video. In this video, I'm not going to discuss about the carbon and its compound in detail. We will discuss only exam-oriented topics and important questions so that after watching this video, you can be able to get maximum marks in this chapter. Okay? Before starting this topic or the chapter, I request you all to like, share and subscribe my videos. Okay? Thank you so much. And I request you to be reading with the pen and a copy so that you can read or write some important points. Okay, thank you. Let's start with the carbon and its compound. You know that the carbon, the symbol of the carbon is 6, capital C. Okay, I'm saying symbol of the carbon is 6. Not the symbol of carbon is C and its atomic number is 6 while its mass number is 12. Another important point, my dear student, that the carbon is the most versatile element in the world. Why? Because carbon can form maximum number of compound, even more number of compound than all the rest elements taken together can form in the periodic table. Another important point in the earth crust, my dear student, carbon is present in 0.02%. Carbon is present in 0.02% in the form of minerals. While in our atmosphere, the content of the carbon is 0.03% in the form of carbon dioxide. And the fourth important point is that all living structure, it means you and I, everyone is composed of carbon or all living structure are carbon-based structure. Another important point, my dear student, that the carbon is present in paper, plastic, leather, rubber, in everything and many other things that you can think of, carbon is present there. Okay. Now moving to the next point that why carbon is forming covalent compound. You know that the electronic configuration of carbon, let me 1 minute, give a time. Electronic configuration of carbon, you know the atomic number of carbon is 6. So the electronic configuration of carbon will be 2 and 4. It means in the valence shell, the carbon has 4 electrons. So my dear student, you must remember that the valency of carbon is 4. It means carbon can form maximum of 4. So we can say that the carbon is also tetravalent. Tetravalent. About the tetravalent and valency we will discuss in detail in the upcoming topics. Okay. So if the carbon has 4 electrons in the valence shell, and you know every element tends to occupy the noble gas configuration. Noble gas configuration or tends to complete their octet. It means having 8 electrons in the valence shell. So carbon also try, but it remain unsuccessful. It could not gain or lose 4 electrons. Carbon try to gain 4 electrons to form C4 minus ion. Carbon gain 4 electrons to form C4 minus ion, but you know, my dear student, it would be difficult for the nucleus to hold 4 extra electrons. A nucleus having 6 protons could not hold total of 10 electrons, so carbon found it very difficult to gain 4 electrons. So carbon say, oh, I'm not going to gain 4 electrons. Carbon rejected this concept. Another point, my dear student, if carbon failed to gain the 4 electron, he tries. What? He tries to lose 4 electron. Lose 4 electron. After losing 4 electron from C4 plus, try to lose 4 electrons. But, you know, To lose 4 electrons, it requires a very large amount of energy. It requires, my dear student, very large amount of energy that is very difficult to provide to the carbon atom. So carbon think, oh, both the options is cancelled for the carbon. Carbon could not gain 4 electron and could not gain lose 4 electron. Okay, so losing and gaining concept is rejected for the carbon atom. So carbon cannot form. Tell me, carbon cannot form ionic bond. Carbon cannot form ionic bond. So carbon have to form bonds. What kind of bond carbon will form? If carbon could not form the ionic bond, then there is another option. Think about it. Can you comment? Yes, carbon can form the covalent bond. Carbon can form the covalent bond. And what is covalent bond and why carbon choose to form the covalent bond? We will discuss about it in detail now. As the carbon could not gain or lose 4 electron because large amount of energy is required and it is very difficult for the nucleus to hold 4 extra, or you can say total of 10 extra electron with 6 protons only. So carbon could not lose or gain 4 electron. Carbon could not lose 4 electron or lose or gain 4 electron. Okay. So what the carbon do? Carbon attain the noble gas configuration by sharing its valence electron. So if there is a concept of sharing of electron, we will say that the carbon will form covalent bond because covalent bond means, or you can say the covalent bond means sharing of electron with other atoms of the element like hydrogen, oxygen, nitrogen, chlorine also form sharing a bond by the sharing of electron. It means carbon is going to form covalent bond by the sharing of electron. It does not mean that only carbon will form the covalent bond. Many other elements like oxygen, nitrogen, chlorine, and hydrogen will form the covalent bond. In general, my dear student, non-metals form the covalent bond, while the metals and non-metals will form the ionic bond. Okay. Now we are moving upward and discuss about where electrons belong to the outer shell of both the atoms. It means carbon is forming the covalent bond. There is a sharing of electron. So the atoms that can be carbon, hydrogen, carbon, oxygen, and other elements that come to form the covalent bond will share their valence shell electron or the outermost shell electron, which thereby achieve the noble gas configuration. We are going to discuss the examples of hydrogen, oxygen, and the nitrogen. Okay, must remember till now what we learned. You must remember that the carbon will form covalent bond. So we are going to discuss the bonding in hydrogen. These topics are not so important, so I'm going very fast. Hydrogen molecule. Hydrogen has 1 electron in the valence shell. So by the sharing of one electron, it forms a single covalent bond. Let me tell you one thing, and also we will discuss it later also, that if there is a sharing of one pair of electron, one electron, it will form single covalent bond. What it will form? Single covalent bond. Okay, if there is a sharing of two pair of electron, it will form double bond. And my dear student, if there is a sharing of three pair of electron, it will form triple bond. Remember this point, I will discuss in detail about these points. Okay. If there is a sharing of one pair of electron, it will form single bond. If there is a sharing of two pair of electron, it will form double bond. If there is a sharing of three pair of electron, it will form the triple bond. But my dear student, there is an exception in case of hydrogen. There is no need to complete the octet for the hydrogen. Hydrogen always forms the doublet completion. Okay. So the hydrogen will form one bond and the bonding in hydrogen can be represented like this. There is a single bond between the hydrogen atom. Okay, clear to you? Single bond in hydrogen atom. Now moving to the next structure. See the molecule of oxygen molecules. Here, in case of oxygen, if you write the electronic configuration of oxygen, see here, K shell and L shell. Okay. How many electrons in the K shell? We have 2 electrons in case of oxygen and 6 electrons in the valence shell. So oxygen have 2 electrons short to attain the noble gas electronic configuration. So oxygen will share 2 electrons. If it is going to share the 2 electron, it will form the double bond. There will be a double bond between the oxygen atom. Okay. Now let's discuss about the bonding in the nitrogen molecule. In the nitrogen molecule, let me tell you one thing that K shell, L shell. In case of the nitrogen, atomic number is 7. It has 2, 5. 2 and 5. It's short by how many electrons? To attain the noble gas configuration, 3 electrons pair. It means nitrogen have the shortage of 3 electrons to attain the noble gas configuration. Okay, so we only show the valence shell electron. We are only showing the valence shell electron. Nitrogen has 5 electrons in the valence shell, and this nitrogen also has the 5 electron in the valence shell. So this nitrogen wants to gain 3 extra electron, and this nitrogen also wants to gain the 3 extra electron. So they share these electrons. This nitrogen has total of 5, and this share these 3 electrons, these 3 electrons. Now this nitrogen have total of 8 electrons, and similarly this nitrogen also share the electron, and now also have the total of 8 electrons. There is a sharing of 1, 2, and 3. 3 pair of electrons, so the nitrogen will form triple bond, as you can see. I think it is clear that the hydrogen, oxygen, and the nitrogen will form covalent bond, and hydrogen, my dear student, will form a single covalent bond. You must remember this topic is very important. And the second point, my dear student, that oxygen will form a double covalent bond, that is double bond, while the nitrogen will form the triple bond. If there is a sharing of 1 pair of electrons, it will be called the single bond. If there is a sharing of double pair of electrons, it will be called the double bond. And if there is a sharing of 3 bonds, it will be called the triple bond. Is it clear to you all? Okay. Let's start with the important topic. Yeah. See, these structures of water molecules, structure of carbon dioxide structure. You can take the screenshot, and I know that you can draw all these structures. These structures are easy and not so important for the carbonate compound. They have a lot of things to ask from you in the carbonate compound. Rarely they will ask the structure of water and H2S and H3. But my dear student, I'm saying that this topic is important. One thing, 1 minute, 1 minute. Yeah. Among all these structure, my dear student, the carbon dioxide structure is important. So please take care of the structure of the carbonates compound and remember the structure of carbon dioxide. Okay. Now, moving to the next point. Before that, let me erase it. Moving to the next point, and this key point you must memorize, my dear student. I already explained all these points, but before going ahead, it's my responsibility to make it crystal clear to you. The first point we discussed that it is the number of shared pair of electron can be 1, 2, 3. It means if the number of shared pair of electron is 1, there will be a single covalent bond. If the number of shared pair of electron is 2, there will be double covalent bond. If the number of shared pair of electron is 3, there will be triple covalent bond. But I think you all have a notebook. Remember, some elements form single covalent bond, some elements form double covalent bond, some elements will form triple covalent bond. But, my dear student, are you listening to me? Carbon is the unique element. Carbon can form single covalent bond, carbon can form double covalent bond, carbon can form triple covalent bond. It's unique now. Yes. Carbon can form single, double, and triple bond in different conditions. Have a different name. We will discuss about it in the next part of this video. Okay, let's start. Another point, the bond formed by the sharing of electron between the two atoms is called the covalent bond. This definition is important and I know that it is clear to you. It's the definition of the covalent bond. Covalently bonded molecules have a low melting point. This is the properties of the covalent bond. Covalently bonded molecules have a low melting point. It means carbon and its compound, the compounds of carbon, methane, ethane, propane, and all the compounds of carbon have a low melting and boiling points. Okay? And because of comparatively weak intermolecular forces, unlike ionic compound. Unlike ionic compound, why? Ionic compound have a high melting and boiling point. They have a strong electrostatic force of attraction between the atoms forming the ionic bond, while covalent bonds are loosely held, having low melting point and boiling point. Remember, all the covalent compounds, that is the compounds of carbon, have low melting and boiling points. Another important point, ionic compound, as the word itself indicates, ionic compounds have ions. If there are ions like H plus, Cl minus, this type of ions are there, they will be responsible for the conductivity of the molecules or the liquid solution in which they are present. But the compounds of carbon are forming covalent compound, so they are the poor conductor of electricity. My dear student, you should note down this point because no charged particle or ions are present. The molecules are generally the poor conductor of electricity since there are no charged particle. But there is an exception. If you know the exception, please comment. What is the exception that one of the carbon compound or, let me clear, one of the allotropes of carbon is a good conductor of electricity? Can you tell me? Yes. Please comment. Okay. Now, till then you comment and I'm going to discuss the allotropes of carbon. This is the most important. At least one question will be asked from this topic, the allotropes of carbon. The allotropes of carbon. First of all, what do you mean by the word allotropes? Tell me. Anyone in the class can tell me what you mean by the word allotropes. If you are watching online, you can comment or you can write in the comment section what is the definition of allotropes. Allotropes are the different form of the same element. Different form of the same element having same chemical and different physical properties. Let me revise the definition. Allotropes are the different form of the same element having different physical properties but same chemical properties. I will explain, don't worry. And never try to memorize. Try to understand the concept. Which is the definition of allotropes. Diamond. The formula of the diamond is C. Graphite. The formula of graphite is C. The fullerene or Buckminster fullerene, the formula of fullerene is C or sometimes it can be written as C60. Chemically, diamond, graphite and fullerene is same. It means they have same chemical property. They will react almost in the same way chemically. Okay, but diamond is the hardest natural substance. Graphite is not so hard, it's soft. Diamond is the bad conductor of electricity. Graphite, exceptionally a good conductor of electricity. I think you commented this. Graphite. I will discuss why the graphite is a good conductor of electricity, exceptionally being a non-metal. Okay. Fullerene have a football-like structure. It means physically diamond, graphite, and fullerene are different, but chemically they are same. That's why, and also they are the compound of the same element carbon. So can I revise the definition? And definitely this time you will understood what are allotropes and will never forget. Let me revise. Allotropes are the different form of the same element. Here, diamond, graphite, and fullerene are the different form of carbon. Okay, different form of the same element having different physical properties. They all, diamond, graphite, and fullerene, I already explained, are physically different. But they are chemically same. Moving to the next point, diamond, each carbon in the diamond is bonded to the four other carbon atoms. What I want to say is suppose it is the carbon atom. It has a little tetrahedral-like structure, and each carbon atom that is at the center, this carbon atom is connected to 1, 2, 3, and 4. Each carbon atom is bonded to the 4 carbon atom, and diamond has a tetrahedral-like structure. Well, graphite, each carbon atom is bonded to the 3 carbon atom. Okay, it means one of the carbon atom is not connected, one of the electron is free, the fourth valence electron can move, and thus graphite become a good conductor of electricity. This is the explanation that graphite is the good conductor of electricity due to the presence of free electron. If someone asked in the exam why graphite is a good conductor of electricity, you will say that in graphite, each carbon atom is connected to 1, 2, 3. Only 3 carbon atoms, and one of the carbon electron is free. This free electron makes the graphite a conductor of electricity. Fullerene. The smallest fullerene has 60 carbon atom. Actually, my dear student, you have to learn only C60. There are C70 and C95 fullerene is possible, but it's not important. The smallest fullerene has 60 carbon atom. Okay, the fullerene has a football-like structure. Remember this. They may ask that which allotropes of carbon have football-like structure. Your answer will be fullerene or Buckminster fullerene. Okay. One thing that is important, my dear student, is the uses of these allotropes. I'm going to discuss the uses in very fast. Diamond, making jewelry and thermometers. Okay. Graphite, pencil leads, electrodes, and the lubricants it is used. These allotropes have the same chemical properties as I already told you. They have the same chemical properties, but they are physically different. Okay. But graphite and diamond is the most important among fullerene they will ask you. So you must know at least 2 or 3 differentiating points between the diamond and the graphite. Let me explain you. You know that diamond, it is the hardest natural substance, but graphite, opposite, is soft. You are using in your pencil. The graphite is very soft. It is the insulator of electricity. It means diamond could not conduct electricity, but the graphite is a conductor of electricity. Why? Graphite is a conductor of electricity because it contains one free electron. But my dear student, diamond is a conductor of heat. If you keep a diamond in direct sunlight, it will become heat, hot. It means diamond is absorbing the heat. So diamond is the good conductor of heat but bad conductor of electricity. And my dear student, you know that the graphite is a good conductor of heat as well as electricity. If you keep the graphite rod in open sunlight, it will get heated. Okay. Diamond, you know, transparent in nature, while graphite is opaque. Okay. Now is it clear the what are the allotropes of carbon and the difference between the diamond and graphite? Is it clear to you? If you have any doubt, you can write in the comment section. I will answer. Okay. Now, moving to the next point that I promised that we will discuss why carbon is the most versatile element in the world. Okay. Versatile nature of carbon atom. Let's start. The 3 important properties of the carbon atom enable carbon to form large number of compounds. The first one is the catenation. If you know the definition of catenation, please write in the comment section. And second one is the tetravalency, having the 4 valency. And the third one is the isomerism. If, my dear students, someone asks why carbon is forming such a large number of compounds, then you will answer the first reason is catenation, the second reason is tetravalency, and the third reason is isomerism. You want to know about the catenation, tetravalency, and isomerism in detail? Let's start. But remember, carbon is forming such a large number of compounds due to catenation, tetravalency, and isomerism. We'll discuss in detail now. Catenation. Okay? What do you mean by the word catenation? Catenation is the self-linking ability. It is a long definition. I just want to write in short. Catenation means you must remember like self-linking ability of element. I'm using the word an element. It means other than carbon, some elements are also showing the catenation. You will discuss about learn about catenation in detail in class 11. But in class 10th, we are discussing catenation related to carbon only. Okay. What is catenation? The self-linking ability of an element. Carbon link self-link means carbon connected with the carbon, carbon, carbon. They form a long chain or either branch chain and different type of chains. We will discuss about it. The first reason carbon is forming such a large number of compounds due to catenation, and the second reason is the tetravalency. You know what tetravalency means? Having four valency. Because its electronic configuration of carbon is 2, 4, having 4 electrons in the valence shell, so the valency of carbon is 4. Okay? Having valency 4, carbon atom is capable of bonding with the atom of oxygen, hydrogen, nitrogen, sulfur, chlorine, and other elements because of its tetravalence. The size of the carbon atom enables the molecules to hold the shared pair of electrons strongly. Shared pair of electrons strongly. Thus, the carbon compound are stable in general. It means the compound of carbon are stable in general. Okay. Another topic we have to classify the compounds of carbon as saturated hydrocarbon, unsaturated hydrocarbon. We will discuss about it in next video, that is part 2 of the carbon and its compound. Thank you for watching this video, and please don't forget to like, share and subscribe. Please share among your friends also. Thank you so much for watching this video. We'll meet you in the next video soon.